Ma'am, shall we start?
Yes, ma'am.
Good evening to one and all. We are delighted to welcome our esteemed dignitaries, eminent resource persons, academics, researchers, and all energetic participants. On behalf of VISTAS, it gives me a great pleasure to welcome you all to the Faculty Development Program on Cloud-Based Data Science, Architectures, Tools, and Best Practices, organized by the Department of Applied Computing and Emerging Technologies. To formally commence the program, I now invite Dr. Y. Kalpana, Professor, Department of Applied Computing and Emerging Technologies, VISTAS, to deliver the welcome address and share insights on the objectives and vision of the FDP. Over to you, ma'am.
Thank you, ma'am. Happy evening to one and all connected here. It gives me immense pleasure to extend a warm and heartfelt welcome to everyone gathered here for third day of the Faculty Development Program on Foundations of Cloud-Based Data Science, Architecture, Tools and Best Practices. At the outset, I warmly welcome our respected resource person of today's session, Dr. J.R. Jabba, Professor, Department of Computer Applications, Nurul Islam Center for Higher Education, Kanyakumari, who is going to share her knowledge with us about cloud application development. She is a distinguished academician and expert in the field who has graciously consented to share her valuable insights and practical knowledge with us today. We are truly honored to have you for this FDP, ma'am. And we look forward to an enriching and intellectual simulating session. I also take this opportunity to welcome our organizing committee members, faculty participants, and research scholars who have joined from various institutions. I hope this session will be a productive and knowledge acquiring one. Thank you all. Have a great session.
Thank you, ma'am, for such a warm and inspiring welcome. I now would like to invite Dr. V. Subha, Assistant Professor, to introduce our chief guest to the audience.
Thank you, ma'am. It's a great honor to welcome our respected chief guest, Dr. J.R. Jabba, Associate Professor and Head of the Department of Computer Applications. Dr. J.R. Jabba is a highly accomplished with 28 years and 9 months of teaching experience and 15 years of research experience. Her areas of specialization include data mining, software engineering, and image processing. She has taught to a wide range of subjects such as software engineering, object-oriented programming, visual programming, Python programming, and image processing. Dr. Jabba has made significant contributions to research with 33 international papers and 7 national journal publications, and has presented papers at both national and international conferences. She has also successfully guided several research scholars with 5 PhD completions and 6 ongoing. She is also a patent holder with 2 granted patents and the author of the book Java Programming 2024. Dr. Jabba actively contributes to academic communities as a BOS member, doctoral committee member in reputed universities, reviewer for international conferences and journals, and a life member of the Indian Society for Technical Education. We feel privileged to have such a distinguished personality among us today. Let us warmly welcome Dr. J.R. Jabba, ma'am.
Thank you, ma'am, for the wonderful introduction. I now invite Dr. J.R. Jabba, ma'am, to kindly take over the session.
Good evening to everyone. I am Dr. J.R. Jabba, Professor, Department of Computer Applications, Nurul Islam Center for Higher Education. Okay, at the outset, I would like to thank the organizing committee for giving me this wonderful opportunity to interact with you all through this faculty development program on cloud application development. It is truly a pleasure to be a part of this academic initiative. And during this FDP, we will explore the fundamentals of cloud computing, various service and deployment models, cloud native application development, and best practices followed in the industry. Cloud computing has transformed the way the applications are designed, developed, and deployed and managed. And learning becomes more meaningful when it is collaborative. Once again, I thank the organizers and all the participants for being part of this FDP. I hope this program will be a valuable and enriching learning experience for everyone. Thank you, and let us begin the session. Am I audible?
Yes, ma'am.
Yes.
So today my topic is cloud application development. So the cloud application development, I think you know that this refers to the process of designing, building and deploying and managing applications that operate on cloud computing platforms. These applications are developed using cloud native principles such as scalability, then elasticity, then high availability, and automated resource management. So in other conventional software applications, unlike the other conventional software applications, cloud applications are designed to leverage the distributed computing resources. They can automatically scale up or down based on our user demand and ensuring optimal performance and cost efficiency. So this cloud application development makes use of service models like IaaS, PaaS, and SaaS. All of you know this, allowing the developers to focus more on business logic rather than infrastructure management. So the modern cloud applications often adopt microservices architecture, then serverless computing, then DevOps practices to achieve the faster development cycles and continuous delivery. Then understanding the cloud computing fundamentals and service models. So it is an on-demand access to shared computing resources such as servers, storage, then other applications, then services over the internet, and minimal management effort. It allows the organizations to consume IT resources. So it follows the method as pay as you use model. Pay as you use the model. Okay. Then there are some fundamentals. The core fundamentals of the cloud computing are there are some devices. Core computing are some on-demand service. You can say that. Then broad network access. Then resource pooling. Then rapid elasticity and measured service. And then IaaS. So that is an infrastructure as a service. So this provides virtualized computing resources such as virtual machines, then storage and networking. Then users have control over operating systems and applications, while the cloud provider manages the underlying hardware. Okay. Now example for this is AWS, then Microsoft Azure. This follows this IaaS method. Then next one is the PaaS. PaaS represents platform as a service. This platform as a service, it offers a complete development and deployment environment, totally a deployment environment like runtime and middleware, then development tools. Okay. It allows developers to focus on application development without managing the infrastructure. So example is Google App Engine. We can say that the best example is the Google App Engine. Then the next one is a SaaS, SaaS, that is a software as a service. So it delivers a fully functional and software applications over the internet. Users can access the applications directly through the web browser without installation or maintenance. So best example is a Gmail or Microsoft 365 Gmail is the best example. So far there are three main cloud services models are available: IaaS and PaaS and SaaS. Then the importance of these models, we can say that it provides a varied level of control and responsibility and enabling organizations to choose the most suitable model for our application, and it will maybe based on a cost, then flexibility, and then scalability, and then operational requirement. The next is for the cloud application development. This is the most important topic, step for choosing a right cloud platform. So the choosing the right cloud platform is one strategic decision that impacts application performance. Is again a scalability, security, and overall cost, etc. And the selection depends on technical requirements, business objectives, and then long-term sustainability. So the selection fully depends upon a technical requirement. Okay. Selecting the right cloud platform is a critical decision. Actually, it is a critical decision for all the organizations. Most cloud providers are like Amazon Web Services, Microsoft Azure, and then Google Cloud Platform. So these offer a unique strength. Each service offer some specific facilities, and the choice of the platform depends on factors like existing IT infrastructure, service requirement, and pricing models, and scalability needs, and integration with the current systems. And then first one is an Amazon Web Services. Amazon Web Services, it's a market leader in cloud computing, and it has a global infrastructure, and it's an excellent for startups and enterprise requiring comprehensive cloud solutions with a proven reliability. And it offers an extensive range of services and a highly reliable and global infrastructure. And it is often mainly used by more organizations, or most of the organizations are using the services, and this is suitable for the startup also. Okay, and next is a Microsoft Azure, and this provides a seamless integration with the Microsoft ecosystem, including the Windows Server. And then this is for organizations already using a Windows Server and Active Directory and .NET technologies. And it is particularly well suited for enterprises that already rely on Microsoft products and require a strong hybrid and cloud and enterprise grade solutions. This also is used by most of the organizations, Microsoft Azure. And next is Google Cloud Platform. It is known for its advanced data analytics, machine learning, and then AI capabilities. And it is an excellent choice for the organization focusing on big data processing, artificial intelligence workloads, and container using a Kubernetes, etc. Okay, and also we can say that for selecting the right cloud platform, it may also depends upon the application requirement. Then maybe depend upon the service model. Service model support, that is an IaaS, PaaS, and SaaS, and then scalability and performance, and then it also depends upon security, then a cost and pricing model, and then integration and ecosystem. Then okay, that's all. That's all about some factors for choosing cloud platform. So most commonly, Amazon Web Services, Microsoft Azure, and Google Cloud Platform are being used by the organizations. And next is the cloud native architecture patterns and microservices design. So it refers to the designing applications specifically to fully leverage cloud computing capabilities such as scalability, then elasticity, then automation. So instead of building monolithic systems, the compiled architecture, the microservices as a core design approach. So this diagram shows the monolithic decomposition, microservices, then orchestration, and then cloud native. So this diagram illustrates the evolution of application architecture from a traditional monolithic system to a modern cloud native architecture. Initially, the applications are developed using a monolithic architecture where the entire system is built and deployed as a single unit. While this approach is simple to design, it becomes difficult to scale and maintain as the application grows. Okay. To address this limitation, the application undergoes decomposition. That is the next process, decomposition. So this where it is split into a smaller modules based on a functionality and also a well-defined boundaries, and split by modules and boundaries. There are so it will be divided into more modules and also a boundaries, and this process prepares the system for microservices approach. So this will be an input for this one. Okay, the next process. So in the microservices architecture, each module becomes an independent service with its own functionality and communicates with other services through well-defined APIs. These services, so it's mainly depends on with an APIs. These services can be deployed, okay, and then scaled independently, and the maintainability is also a more. Okay, the next is an orchestration, and this is the next stage where the microservices are packaged into containers and managed at scale using orchestration tools. So the containers managed at scale, and then it also load balancing and fault recovery. It will also be done automatically. And finally, it is a cloud native. The system becomes a cloud native. The cloud native meaning it is fully optimized for cloud environment. This cloud native architecture is highly scalable and also capable of handling dynamic workloads. And then can also say that it is a distributed infrastructure. It uses the feature, the distributed infrastructure. So this architectural evaluation represents the journey from the traditional monolithic applications to fully cloud-native microservices. Okay. Monolithic, decomposition, microservices, orchestration, and then cloud-native. And there are some key design principles for this. Key design principles are service independence and loose coupling, and then distributed data management, and then fault tolerance, and then API first design approach, and containerization and orchestration. Then this architectural evolution, this says that this is a progression from a traditional application to modern microservices based system. So initially the applications are built as monoliths, where all the components are tightly coupled and deployed together. So to improve the scalability and flexibility, these applications are decomposed into smaller functional units with well-defined boundaries. So each microservice operates independently, and then it communicates through APIs. Then it is managed using orchestration tools, and then finally resulting a fully cloud-native architecture. Okay, then this cloud-native microservices allow the applications to scale individual services independently based on demand. This approach eliminates the need to scale the entire application, leading to better resource utilization and improved performance and reduced operational cost. And this microservices enable the flexible deployment flexibility. The strategies by allowing the updates to be applied to specific services without affecting the entire application. Okay, without affecting the entire applications, it updates some specific services. And this supports the continuous integration and continuous delivery practices, and reduces deployment risk and minimizes downtime. And next is a technology diversity. And this cloud-native microservices architecture supports a technology diversity by allowing each service to use the most suitable programming language, framework, or database. So this flexibility enables the teams to adopt new technologies without architectural constraints. Okay, so this is about the cloud-native architecture patterns and microservices design. The next is development tools and IDEs for cloud applications. Integrated development environment for cloud applications. So it relies on a wide range of tools and also an integrated development environment that supports building, testing, deploying, and managing applications in cloud environments. And it improves the developer productivity also, and it enables the automation. Then, so one of the tool IDE used for a cloud application is Visual Studio Code. And this is a powerful IDE, widely used for a cloud application development, and it supports multiple programming languages and offers an integrated terminal along with extensive extensions, and then plugins for cloud platforms such as AWS, Azure, and then Google Cloud enable the cloud development and then deployment. So Visual Studio Code is mainly used for cloud application development. So it may be a better choice to use the Visual Studio Code. Then another one IDE used for developing a cloud application is the Java based. So that is called IntelliJ IDEA. Is a Java focused IDE. So here it uses the debugging capabilities. It has some more debugging capabilities, and it is especially suitable for developing Spring Boot based microservices. Okay, and it has a built-in support for Docker and then cloud native application development. It is also being used by most of the companies, organizations for developing a cloud application. So another one IDE is Eclipse IDE. It is an open source IDE. It's popular for Java enterprise application development. It offers a strong plugin ecosystem. That's the main important one. Plugin ecosystem that supports cloud deployment and container management and microservices architecture, making it suitable for large-scale cloud projects. Okay, the next one is the Cloud CLI tools. It is another one IDE used for a cloud application. So Cloud CLI tools are command line interfaces provided by cloud services such as AWS, Azure, then Google Cloud, etc. So all these tools are used for automation, scripting, and then cloud resources. So managing all the cloud resources efficiently, and also we can integrate all with an IDEs, etc. So these are some few IDEs nowadays the companies are using for developing cloud applications. So we have to choose the right tool for improving the developer productivity and the overall code quantity and efficiency. So we can use the modern cloud applications, it must require an IDE. So because without an IDE, it is too difficult to create a cloud application. So we must use an IDE for creating the cloud application. Okay, so it requires an IDE, and also it supports a debugging process, and also all the IDEs are using a control version control integration, and then direct integration cloud services. Okay. The next, database solutions. SQL versus no SQL in the cloud. Okay, the cloud applications, all the cloud applications are using the databases as a backend, and this require the database solutions. In cloud environment, all the databases are classified into SQL and no SQL. No SQL is a non-relational SQL databases, each serving different application needs. And then in cloud computing, we have to choose whether it's an SQL based or a no SQL databases. And then it maybe depends upon the factors such as data structure, scalability requirements, then transaction complexity, etc. And then both database models offer a unique advantage and are widely used in the cloud environment. Okay, so let's see one by one the SQL databases. These SQL databases are generally, the relational databases that store data in structured tables with the predefined schemas. They support a complex queries, structured query language. So it's support as complex queries and follow the principle like we know this ACID in the sense atomicity, consistency, isolation, and durability. That is an ACID properties. It follows ACID properties in an SQL databases. And ensuring the strong data consistency and reliability. And it is ideal for applications that require an accurate transactions and structured data, and all the ERP applications, and also an inventory management system, and whatever it may be. If you are using a databases, we must use an SQLs. Okay, so that is an SQL databases. And no SQL databases are designed to handle large volumes of unstructured or semi-structured data. Okay, but SQL databases use only structured databases so that they can apply the SQL correctly. If we apply the SQL, we will get the correct output from the databases. But no SQL databases follows it is an unstructured or semi-structured data. It has a flexible schemas and are optimized for horizontal scalability and high performance. And high performance. No SQL databases are suitable for big data applications and real-time analytics and content management systems and applications with rapidly changing data models. And common NoSQL databases are graph databases. We can say that a graph databases and key value stores databases, and then time series databases. So these are NoSQL databases because it is an unstructured one and it is a semi-structured data. So we can use SQL and NoSQL for the cloud applications. So if we have a structured data, then we can use an SQL queries. We can apply the queries. But if we have a unstructured data for cloud applications, we can apply, we can use the NoSQL databases. So both are valid. Based on our availability of databases, we can use it. Whatever it may be, a SQL or NoSQL databases. So this Amazon RDS provides this Amazon RDS provides manage the SQL databases with automated backup and scaling support. And then Azure Cosmos database. It's a globally distributed NoSQL databases. This is a NoSQL database offering a multi-modal support. Okay? And this Amazon provides an SQL databases, but Azure Cosmos database, it provides the NoSQL databases. And then Google Cloud Spanner, it combines both. It has both SQL consistency with the NoSQL. Okay, and then MongoDB Atlas is also be used for the cloud application. MongoDB is a fully managed document-based NoSQL NoSQL database designed for modern application development. So most commonly we are having a NoSQL. So some unstructured data are available. So for the cloud applications, we can use the NoSQL also, but it should support that. But Amazon uses an SQL database. Azure Cosmos database, it uses a NoSQL, and then Google Cloud, it uses both SQL as well as NoSQL database, and MongoDB, it uses a NoSQL database. And this chart represents whether, so it's a different types of databases used in the cloud environment based on their usage and suitability for various workloads. And the first one is a relational SQL. This is used widely for the applications that require structured data and strong consistency. Then it stores the data in tables with the fixed schemas and support complex queries. And next is a document-based NoSQL. This is it stores the data in flexible data documents. Then these are highly scalable and well suited for modern web and mobile applications. Okay. And next is a key value store. Key value stores, it provides very fast data access by storing the data as simple key value pairs. They are designed for high performance and large scale distributed systems, making them ideal for batching, session management, and real-time applications. And next is a graph database. Graph databases it mainly focus on the relationship between data entities. They are best suited for applications like social network, like share market or any other chart related matters, recommendation system, fraud detection, then etc. Okay, and next is a time series database. These are optimized for handling data that changes over time. They are commonly used in monitoring systems like IoT applications and performance analytics, etc. Okay, overall the chart highlights the cloud platforms support a variety of database types, and each for specific application needs. And then, yes, the next is API development integration strategies used in the cloud application development. API is nothing but an application programming interface. It places, so by enabling a communication, between the distributed system, microservices and external systems. Distributed services are microservices with an external system. So the maintainability, well-designed APIs ensure the maintainability. And then, so there are some steps for developing an API for the cloud application. Well-designed APIs improve the security also, okay, and overall developer experience, and also a cloud-native architecture. Okay, the first is a design first. Design and define API specification using OpenAPI or a GraphQL schemas before implementation. Okay, and so this is the first step for designing API development, and then it should be a clarity, and then consistency, and also you have to specify the better collaboration between the development teams to a well structured and easily maintainable APIs. So we have to clearly specify what are the so where it is connected and where the collaboration is. Okay, and second step is a secure authentication. So it is nothing but a security. You have to confirm the security also. This is one of the critical aspect of the API development, and it has a JWT tokens and API keys are implemented to control the access and protect sensitive data and prevent unauthorized usage of APIs. Then version management. This API versioning helps maintaining a backward compatibility while allowing the continuous improvement. Then the semantic versioning enables the developers to introduce the new features. Okay, and next is a rate limiting. Rate limiting protects APIs from abuse and overload. That's the rate limiting. By restricting the number of requests from a client within a specified time. Within a specified time, you can restrict that, the number of requests, so that this APIs restrict the abuse and overload. Okay, so a few APIs, sir. RESTful APIs. This is a standard HTTP based architecture. It is a strong support across the platform. Then GraphQL. GraphQL is the query language that allows the clients to request the specific data, exactly the data they need. Okay, specific data, exactly the data, and it reduces overfetching and underfetching of data, overfetching as well as an underfetching. Then it provides flexible data services, data retrieval, and then strong typing and making it as ideal for a complex application. So GraphQL, and then next is a gRPC. So it is also a high performance remote procedure called framework. It also buffers for efficient data serialization. The main thing is a serialization. It is used for an internal microservices. Okay, so these are the steps in the API development and integration strategies. Design first and secure authentication, and then version management and rate limiting. You have to specify. These are the 3 APIs most commonly used for the cloud application. The next is security best practices and compliance considerations. Security is the most important factor for while developing the cloud application. So if there is no security, then everything will be lost, the data will last. The security, it is due to shared responsibility model. The security, we have to maintain the security, where both the cloud service provider and the customer have defined security rules. We have to define the security rules, and then implementing strong security practices and ensuring the compliance also for protecting the data, applications, and infrastructure in cloud environments. Okay, and then security best practices and compliance considerations. And security must be embedded throughout the cloud application development lifecycle. The cloud environments introduce the unique security challenges that require the protecting data. Okay. Then identity management. So in the security, the identity and access management It's a foundational security practice in cloud systems. Here we can do that multi-factor authentication. Multi-factor authentication, we can do it. So nowadays in mail systems, two-level authentication, etc. is there. Okay, multi-level authentication, multi-factor authentication is essential, and role-based access control and the principle of least privilege to ensure that users and services have only the permissions necessary to perform their task. So nowadays, an iPhones have more security systems like this, and a cloud also has a more security system. And next is a network security, focuses on protecting cloud resources from unauthorized access and attacks. Then we can configure for network security, we can configure for VPNs, virtual private clouds, you can use it, and security groups, you can use it. Then firewalls, you can use it. Then protection services also, we can use it to secure the application traffic. And next is a data encryption. Data encryption ensures, so it is, that means converting a data from one format to another format. The standard encryption methods are used for securing the data through encryption methods, and cloud native key management services are also used to prevent unauthorized data access. And then continuous monitoring, it involves tracking system activity and security events in real time. So cloud monitoring tools and event management systems are used to detect threats early, automate incident response. And then we can do the regular audit for the security. Regular auditing systems and penetrations testing help identify the vulnerabilities in cloud systems. Sometimes new virus or vulnerabilities or security insecure methods may be there in the cloud systems. We have to regularly check it. So these assessments ensure the compliance with the security standards and help the organizations to improve their security. Okay, the next is a patch management. It ensures that operating systems, applications, and dependencies are kept up to the date. Then regular patching reduces the risk of known vulnerabilities. Okay, next is a disaster recovery. So this is it ensures the business continuity in the event of failures and cyber attacks. So failures and cyber attacks, and then reliable for the backup strategies, etc. Okay, so these are the security best practices while developing the cloud applications. So while developing the cloud applications, we have to maintain a security based on this. We have to do the regular audit and patch management, disaster recovery, and also the network security and data encryption, continuous monitoring. So without the security mechanism, so the cloud application is maybe treated as a worst one. So we have to increase the security mechanism while developing the cloud applications. And next is the deployment strategies and CI/CD pipelines and DevOps integration. This cloud, nowadays the modern cloud application development demands fast, maybe a fast and reliable and automated deployment strategies. And CI/CD, it is one of the deployment strategy, and it is always mostly it may be combined with the DevOps integration. And So you can deliver the applications for frequently, consistently, and with a high quality. And next, deployment strategy, CI/CD pipelines, DevOps integration. So there's mostly this cloud applications rely on automated deployment strategies to deliver the software quickly and also reliably, and then with minimal errors. With the minimal errors, it is you can develop the softwares. And CI/CD pipelines form the core of DevOps practices. So it automates the process of building, testing, deploying. So when a software is developed, after that you can to deploy it. So automates. So this practices, this DevOps practices. So DevOps they do by automating the process of building, testing, and deploying applications. And CI/CD pipeline workflow, it begins with the code commit. Where is it? Yes. Code commit where developers push the code to a shared repository. Okay. And then automated build process, it compiles the application and prepares it for testing. This build is followed by unit testing, which verifies the individual components. Okay. And which ensures that different modules work together correctly. So the unit testing, you know that it is tested by the unit by unit, a module by module. It may be followed in the software engineering also. The same thing here. Each code is the same software. This is also a software application. So this is also verified and the individual component, and also it goes for the integration testing. And then only the code that successfully passes all the automated tests is promoted to the production environment. Okay. Then blue-green deployment. The blue-green deployment maintains two identical production environments. One environment handles live traffic, while other hosts the new version of the application. After successful validation, the traffic is switched instantly to a new version and enabling zero downtime releases, etc. And then next is canary releases. So it involves rolling out new features to a small subset of users. And next is rolling updates. Deploy the new application versions across the servers and containers. Okay. The last is the performance monitoring and cost optimization techniques. So we have to follow all these steps while developing the cloud application development. So this performance monitoring and cost optimization techniques is ensuring the high performance while maintaining our cost efficiency while developing the cloud application development. And this continuous monitoring helps identify the performance bottlenecks, predict issues, and reduce unnecessary expenses without compromising user experience. Okay. And then continuous monitoring is the main factor. And then average cloud-based may be there. And then performance gain and resource right sizing. Yes. Then some monitoring tools may be used. Okay. This resource right sizing that represents the actual workload patterns and adjusting instant times and sizes accordingly. Then auto scaling implementation. So it adjusts the computing resources based on the demand, and reserved instances. Um, it allows the organizations to commit long-term cloud resource for predictable workloads, and monitoring tools. Some monitoring tools may be applied. Cloud native solutions, for example, a Datadog. One of the platform is called as a Datadog. So that is used for a monitoring, etc. Okay, so these are the steps for cloud application development. Number one is, and first of all, we have to, so this is a fundamental thing about a cloud computing fundamentals and service models. And then first thing is choosing the right cloud platform, Amazon Web Services and Microsoft Azure, and then Google Cloud Platform. These are the nowadays. These platforms are popular. And next is a cloud native architecture patterns and microservice design. And there are some key design principles for doing this. And next, development tools and IDEs for cloud application. Visual Studio Code, IntelliJ IDEA, and then Eclipse IDE. So these are the IDEs which are used for the cloud application. And then some database solutions, SQL versus NoSQL in the cloud. And next is an API development and integration strategies. So there are some steps for developing an APIs also for the cloud application development. Design first and secure authentication and version management, rate limiting, etc. And then security is the most important factor for developing a cloud application development. And next, deployment strategies, CI/CD pipelines and DevOps integration. And next is a performance monitoring and cost optimization techniques. So these are the stages for developing a cloud application. Okay.
Thank you, ma'am, for your inspiring and insightful address on cloud application development. Participants are requested to feel free to ask questions.
Any questions? The cloud application development. Shall we conclude?
Yes, ma'am. Ladies and gentlemen, as we come to the end of this insightful session, it is now time to formally express our gratitude to everyone who made today's program a meaningful success. I now invite Ms. G. Monica, Assistant Professor DACE, to kindly propose the vote of thanks. Over to you, ma'am.
Yes, ma'am. It's audible?
Yes.
It's audible,
Yes,
ma'am?
ma'am.
Yes.
Yes, audible.
It's my distinct honor and privilege to propose the vote of thanks on behalf of our organizing committee for this third day of DP on cloud application development. We are immensely thankful to our respected founder and chancellor, Dr. Ishari K. Ganeshwar, Pro-Chancellor PND Dr. A. Jothi Murugan, Pro-Chancellor Academic Dr. Arthi Ganesh, VP VELS Groups, Vice President Ma'am Dr. Preethaa Ganesh, Pro-Chancellor SOE Dr. M. Bhaskaran Sir, Vice Chancellor Dr. T. Sasiprabhha Ma'am, Registrar Dr. M. Chandrasekaran Sir, and Convenor Dr. Jothi Venkateswaran Sir, Dean, School of Computing Science VISTAS, Dr. R. Devi, Professor HOD of the Applied Computing and Emerging Technologies, Dr. Booba, Professor. A sincere thanks to a distinguished resource person, Dr. J.R. Jabba Ma'am, Professor, for generously sharing her expertise talk and engaging her precious time with us regarding the cloud application development. Thank you, ma'am. Thank you for your wonderful session.
Thank
Your
you.
expertise talk about service models, how to choose the right platform of cloud computing,
Yes.
and architecture patterns, choosing the right tools for IDEs for creating the cloud application, regarding the database security practices, and all other things you teach very it's very the in expertise manner, ma'am. Once again, I thank you, ma'am,
Thank you.
for your
Welcome.
your contribution is invaluable, ma'am.
Welcome.
I extend my heartfelt thankful to a dedicated organizing committee, Dr. T. Kamalakannan, Professor, Dr. Y. Kalpana, Professor, DACE, Dr. K. Sharmila, ma'am, Dr. K. Kasturi, ma'am, Associate Professor, Dr. S. Jayashree, Miss Mary Shiba, ma'am, Dr. V. Shiba. Thank you for the organization committee, ma'am. And last but not least, and finally, a huge thank you all for all the participants, participating the faculty members. Once again, I thank you all, ma'am. Thank you so much.
Thank you. Thank you. I would also like to express my sincere gratitude to our organizing committee for their excellent planning and coordination, which made this program both meaningful and successful. Okay.
Thank you, ma'am. Thank
I
you
would
so
like
much.
Thank you,
to
ma'am. Dear
thank
participants.
HODs
Yes.
and other organizing members, especially Mr. Booba Rajashekar, Dr. Booba Rajashekar, my friend, for his support and cooperation and contribution during this program.
Thank you, ma'am.
Thank you,
Dear
Jabba.
participants, kindly fill the feedback for the link shared in the chat box. Once again, I thank you all for your active participation and support. Thank you and have a great day.
Thank you.
Hello, ma'am. I couldn't find the feedback link. Please send it again.